Collections.
Janvi, 1 second. Start from.
Uh, should I start from the beginning, sir?
Yes.
Okay.
Hello everyone. I Parthasarathi JN.
And a very good morning, everyone. This is Chanvi TNJ, and today we'll be giving a presentation on the collections.
Collections. What is a collection? Any group of individual objects which are represented as a single unit is known as a collection of objects. Collections in Java are used to perform operations like store, retrieve, manipulate, communicate, and aggregate.
The collection in Java is a framework that provides an architecture to store and manipulate the group of objects. Java collections can achieve all the operations that we perform on a data, such as searching, sorting, insertion, manipulation, and deletion. For better understanding, let us look into some real-life examples of collection. Here in the first image, we can see a classroom in which there is a teacher and a group of children which together forms a collection called the classroom. In the next image, we observe a train that is connected to a bunch of bogies which are similar to each other. Here, the train is a collection. These examples are similar to that of a Java collection.
Collection framework. The Java Collections Framework is a collection of interfaces and classes which helps in storing and processing the data efficiently. This framework has several useful classes which have tons of useful functions which makes a programmer's tasks super easy.
The collection framework represents a unified architecture for storing and manipulating a group of objects. It has interfaces and its implementations, that is, the classes. The primary advantages of a collection framework are that it reduces programming effort, provides ready-made architecture, represents a set of classes and interfaces, and reduces the effort required to design and implement APIs. Now we'll see the diagram of collection framework hierarchy in Java. Here, iterable, collection, list, queue, map, set, dequeue, sorted set, sorted map are interfaces marked in color green. Then rest of them are classes. The hierarchy of entire collection framework consists of four core interfaces such as collections, list, set, and map. The collection interface extends the iterable interface. The iterable interface has only one method called iterator. The function of the iterator method is to return the iterator object. Using this object, we can iterate over the elements of the collection. List, queue, and set have three components which extends the collection interface. A map is not inherited by collection interface. Since we are familiar with queue, let us deal with list, set, and map today.
Java List. List in Java provides the facility to maintain an ordered collection. It contains index-based methods to insert, update, delete, and search the elements. It can have duplicate elements as well. We can also store null values in this list. The list interface is found in java.util package and inherits the collection interface. The implementation classes of list interface are ArrayList, LinkedList, Stack, and Vector. ArrayList. ArrayList is a resizable array implementation of the list interface. The size of an array list increases automatically if the collection grows and shrinks automatically if the objects are removed from the collection. Linked list. Linked list class is an implementation of the linked list data structure where the elements are not stored in contiguous locations and every element is a separate object with the data part and an address part. Stack. Stack class models and implements a stack data structure. The class is based on the basic principle of last in, first out. In addition to the basic push and pop operations, the class provides three more functions of empty, search, and peek. Vector. Vector implements a dynamic array that means it can grow or shrink as required. Vectors are similar to that of ArrayList, but they are synchronized and have some legacy method that the collection framework does not contain. Vector is no longer used in Java. We already know about linked lists, so let us look into what an array list is.
The array list. Java ArrayList class uses a dynamic array for storing the elements. It is like an array, but there is no size limit. We can add or remove elements anytime. So it is much more flexible than that of a traditional array. ArrayList class can contain duplicate items. It maintains insertion order. It is non-synchronized. It allows random access because array works at the index basis. In ArrayList, manipulation is little bit slower than that of linked list in Java because of a lot of shifting needs to occur if any element is removed from the array list. Syntax of creation of ArrayList is as same as creation of an object of a class where ArrayList is the class. In our example code, we create a list of integers. Class ArrayList is present in the package java.util.arraylist. Hence, we import it. We use add method to add integers to our list and remove method to remove an integer, and this program will be executed at the last.
Set. The set interface is present in java.util package and extends the collection interface. It is an unordered collection of objects which has duplicate values and cannot be stored. It is an interface which implements the mathematical set. This interface contains the methods inherited from the collection interface and adds a feature which restricts the insertion of duplicate elements. On the set, we can perform all the basic mathematical operations such as intersection, union, and difference. The set interface is used to create the mathematical set. For the given figure, the navigable set extends the sorted set interface. Since a set doesn't retain the insertion order, the navigable set interface provides the implementation to navigate through the set. The class which implements the navigable set is a tree set, which is an implementation of a self-balancing tree. Therefore, this interface provides us with a way to navigate through this tree. Hash set. Hash set stores the elements by using a mechanism called hashing. It contains unique elements only. It allows for the presence of null values and it is non-synchronized. Hash set doesn't maintain insertion order. Here, elements are inserted on the basis of their hash code. Hash set is the best approach for search operations. Sorted set. The sorted set interface of the Java collections framework is used to store elements with some order in a set. It extends the interface. In order to use the functionalities of the sorted set interface, we need to use treeset class that implements it. The sorted set interface includes all the methods of the set interface. It's because set is a super interface of the sorted set.
Now let us look into an example of treeset. Java treeset class implements the set interface that uses a tree for storage. It inherits abstract set class and implements the navigable set interface. The objects of the treeset class are stored in ascending order. Syntax of creation of treeset is as same as creation of object of a class again, where treeset is the class. In our example code, we create a treeset of integers. Class treeset is present in the package java.util.treeset, hence we import it. We use add method to add integers to our list and remove method to remove an integer. And this program will be executed at the last for better understanding and comparison.
Map. A map contains the values on the basis of key, that is, key and value pair. Each key and value pair is known as an entry. A map contains unique keys. A map is useful if you have to search, update, or delete elements on the basis of a key. There are two interfaces for implementing map in Java, map and sorted map, and there are three classes, hash map, linked hash map, and tree map. The hierarchy of the Java map is shown. Hash map. Hash map is the implementation of a map, but it doesn't maintain any order. Linked hash map. Linked hash map is the implementation of a map, but its hash map class. It maintains insertion order. Tree map. Tree map is the implementation of a map and a sorted map. It maintains ascending order. A map doesn't allow duplicate keys, but you can have duplicate values. Hash map and linked hash map allow null keys and values, but tree map doesn't allow any null key or value.
Let us take the example of hash map. Java HashMap class implements the map interface which allows us to store key and value pair, where keys should be unique. If you try to insert the duplicate key, it will replace the element of the corresponding key. It is easy to perform operations using key index like updation, deletion, etc. HashMap class is found in the java.util package. Syntax of creation of hash map is again as same as creation of object of a class, where hash map is the class. We need to pass the type of key and data type. In our example code, we create a hash map of integers whose keys are again integers. Class hash map is present in the package hash map. Hence, we import it. Use put method to add integer to a list and remove method to remove an integer. Now let us look into the programs. Initially, let us look into what an array list program does. Here we are creating an array list of integers. We add integers 4, 4, 2, 5 and 1 to our array list. And in the output, we can observe that the insertion order is as same as the output. That is 4, 4, 2, 1, 5, 1. And duplicates are allowed. Let us look into the tree set. Here we are creating a tree set of integers. We add elements 4, 4, 2, 1, -6 and 3 to our list. And in the output we observe that it has not retained the insertion order. Rather, it is in the ascending order and duplicates are not allowed. Let us look into the hash set. Here we are creating an hash set of integers. We add elements 4, 4, 2, 1, -6 and 3 to our hash set. In the output we observe that the insertion order is not preserved and also it is not sorted, but it is in some order, that is it is based on the hash key values. Finally, let us look into example of map, that is hash map. Here we are creating an hash map of data type integers and also key whose type is integers. We add element 4 with key 2, element 4 with key 1, element 1 with key 4, element 5 with key 3 and element 6 with key 5. In the output, we observe that duplicates are allowed. Insertion order is not maintained. Rather, it is arranged in the ascending order of the keys. We can observe that the keys are in order, that is 1, 2, 3, 4, 5. Duplicates are allowed. Duplicate data values are allowed. List versus set versus map. Finally, let us draw the conclusion on what we saw. We have the interfaces list, set, and map. Are duplicates allowed? In list, yes. In set, no. And in map, not for keys, but for data, yes. Are null values allowed? In list, yes, multiple times. In set, yes, once. In map for key it is once, and for data it is multiple times. Is insertion order preserved? In list, yes. In set, no. And in map, no. Data structure. Usually for list it is an array, for set it is map implementation, and for map it is hashing technique.
I would like to express my gratitude towards Santosh sir for letting us conduct this presentation, and a huge shout out to our team member Janavi for conducting this. Last but not the least, attention spans of such length are rare in our field. Indeed, we can thank you, the listeners, enough for listening to our presentation with such massive attention. She is. Thank you from the both of us.